Hello and welcome to our video on back-to-back stem plots. Now, a back-to-back stem plot is best used to compare a numerical and a categorical variable, but the categorical variable can have two categories only. It can't have more than two. And that's because we're putting them back to back like this, and there's only two spots where the back-to-back can go. You'd need 3 dimensions if you're going to add a third, or 4 dimensions if you're going to add a fourth. So back-to-back stem plots only use the two categories at a time. Now, if we look at this example that I've got here, this is a phone battery comparison, so between brand A and brand B, and these are the numbers of hours that the battery lasted before it cut out. So our two variables are battery life in hours and brand of phone. So let's check which one's the response in the explanatory. Battery life explains or causes the brand, or the brand causes the battery life. The second one makes sense to me, so I'm going to change my arrow over. Brand causes battery life. And this one where I start is the explanatory variable, and this one's the response variable. When we have our two variables, so the brand is the categorical variable because it's got two different categories, and you're either in brand A or brand B. And the battery life is a numerical variable because it's counting how many hours that the battery lasts for. If we look at just the right hand side of this stem and leaf plot, so just this part here, this is exactly the same as your normal stem and leaf plot. So just ignore this bit for a minute. This is our normal stem and leaf plot. You'll notice it's got a key down the bottom, which is really important to remember. And I might highlight it actually. Our key says that 6-1 is the same as 61 hours. So the stem here is the tens column and the leaf is the ones column. So here we start with 0, this is 7 hours for this data point. Then we go to 10, so this first data point is 1, 0, which is 10. 1, 5, 15, another 15, another 15. And it keeps going all the way to the end here, which is 75 is the last data point. So that's how we read our stem and leaf plot. All we've done here is taken a second stem and leaf plot and we've kind of put it backwards. So it's like a mirror image. We've flipped it around. So we use the exact same stems down the middle. They stay the same. And instead of going from left to right, we go right to left. So this 0 starts with 5, this is the lowest number, 7, 8, and another 8. Then in the tens column, 1, 0 is 10, 11, 14, 17, and 19. And all the way down to 61 is our highest data point on this leaf side of the plot. You need to name your columns. Stem is in the middle, leaf on one side and leaf on the other side, and just make sure that you start from the stem and move outwards for your data points that you add onto the stem and leaf plot. A couple of points here. When you're drawing your back-to-back stem plot, the stem part of the plot must be shared by both data sets in order to compare them directly. It's like when we're doing box plots and dot plots, you need to have them on the same scale. For a back-to-back stem plot, you need to have the stems the same. What we're looking for here is a significant difference between medians, and then we can say there is an association between the two variables. No significant difference in the medians is no association again. When you're writing a report on a back-to-back stem plot, we use our usual SOX, which stands for shape, outliers, center, which in this case will be a median, and spread, which will be range. The most important one to comment on here is the center and the median, but it's good practice to comment on all the others to create a more complete picture of the data that you're describing. Here's an example. The following data was gathered in response to the question, is gender associated with test scores? So the data is listed here for the male scores, and we have the female scores underneath. Two variables we have are gender and test scores. Gender causes test scores, or test scores cause gender. I think we're looking for gender causing test scores. So we'll leave it like that. This is our explanatory variable and this is our response variable. We have this one here is a categorical variable with two categories. You can only be male or female. So we can use our back-to-back stem plot, two categories only. And test scores is a numerical variable because it's numbers of how people have gone in a test. So this test was out of 20, I think. Your job is to draw a back-to-back stem plot to show the data. So you need to draw it up like this. And part 2, write a report on whether the two variables are related or associated. I'm going to give you a minute to pause the video to have a go at doing that yourself, and then we'll go through it together. Pause the video now. Okay, when I'm drawing up my back-to-back stem plot, I'm going to label the column in the middle the stem. I'll put the boys or the male scores on the left and the girl scores on the right. When I'm looking at my stem, these are all 10s. They've all got a 1 in the 10s column. So if I just put a 1 here and put them all in the same category, it wouldn't really show me much about the distribution, because even for the females, they're all 110s. So what we need to do is break it up into groups. So all the stems are going to be the same. In this first stem, I'm going to have, because my lowest number is 12, so I'm going to have 12 and 13, if I had any 13s for the females. In the second one, I'll have 14, 15. I don't have any 14s, so I only got the 15 there. Then I've got 16, 17, and because we've got 16, 16, 16, we end up with 6, 6, 6, which is interesting, Illuminati confirmed, and 7, 7 for 17 and 17. Make sure you've got gaps in between these, so it doesn't look like 67. And then at the end we've got 19, 19, 19, 9, 9, 9. For the boys, I'm starting with 12 again, closest to the stem, 13, 13, 13. Then in the next, so this is 14, 15, we've got 14, 14, 14, and 15, 15. And here we have a 16. Draw your lines in, which for you would be ruled with a ruler. Hard for me to do on my tablet, but you would definitely be ruling them. And you've got your stem plot. Important when you're drawing it to make sure that these numbers are above each other so you can accurately look at the distribution. If you had all these bunched up and these spread out, wouldn't be giving you a good representation of the distribution. Okay, second question is write a report on whether the two variables are related. My report is down here. Again, we're going to talk about the data first and then the what does it mean. And we're going to be focusing on the medians for our information. I'll be highlighting the information that you need, but you can have different words. The distribution, I haven't mentioned in there the display. The back-to-back STEM plots show the distribution of marks for boys is approximately symmetrical, while the distribution of marks for girls is negatively skewed. So this is close to symmetrical, this one here is negatively skewed. Where's my highlighter? Distribution, symmetrical, negatively skewed. The center of the distribution for girls, medium 16.5, is higher than the center of the distribution for boys, medium 14. The girls' marks are more variable, or they have a larger range, with a range of 7, 9 to 12, compared with only 4 for the boys, 16 to 12. Overall, this suggests there is an association. Can't even spell. Between gender and marks for this group of students. Hopefully you got to report something like that. Thanks for watching the video.